All right, this is section 10-2, and we are looking at the hyperbola. We're going to be looking at horizontal and vertical hyperbolas. And like we saw with the ellipse, there's a bunch of information here. I'm going to try and make it as minimal that you have to memorize as possible and teach you how to work with hyperbolas as opposed to memorizing a bunch of h plus or minus a and then k and all of these things in here that you could spend a lot of time trying to memorize stuff, and I'm going to teach you how to do it a little bit more efficiently without memorizing. So, and hopefully understand how the hyperbola works a little bit better. So, a horizontal hyperbola has x minus h squared minus y minus k squared. So with the ellipse, we had a plus sign in the middle. A hyperbola has a minus sign. With the ellipse, a was the bigger number, b was the smaller number. With the hyperbola, it doesn't matter which one is bigger and which one is smaller. The way we tell whether it's horizontal or vertical is which variable is positive. So notice here that the x is positive and we have the negative in front of the y. That means it's horizontal. If the y is positive and the x is the negative one, then that means it's vertical. So whichever variable is positive dictates whether it's horizontal or vertical. A is always first or under the positive one, B is always under the negative one. And it is a slightly different formula for finding the foci from what we used with the ellipse. So H is always with X, and then K is always with Y, and HK is still our center. And we will still be using these A and B values to figure out the shape, but it's a different shape than the ellipse. So hyperbolas, this would be a horizontal hyperbola. This would be a vertical hyperbola where it's going up and down. And the A value tells us our vertices. So I find my center and then I go out the distance of A for my two vertices. And then we don't really have co-vertices. We will still call them co-vertices, but it's not actually a point on the graph. So the B value does tell us this other point. And then you can see this really light box that's drawn here. And this box will help us figure out how steep or how flat our hyperbola is. So if I have these two asymptotes, these diagonals here, and if they're really flat, then my hyperbola will be these curves in here, and it'll be a really steep hyperbola. If my box is really steep like this, then we'd have a really flat hyperbola here. Okay, so the box with the A and B value here determines the shape and how steep or flat our hyperbola is. Notice that the foci are still on this major axis here. In the hyperbola, this is actually called the transverse axis because these points transverse this line. So this transversal axis here has our vertices and our foci are inside the curve here. So they're inside the curve of the hyperbola. And then the B value is just what helps us determine this box here. Now you will also be writing the equations of the asymptotes. And again, it could be more for you to memorize. You'll see two different equations here and here for whether it's horizontal or vertical. But I'm going to show you how to write the equation without having to memorize that. So the only thing you should really need to memorize is how to, these two equations here for the hyperbola, vertical and horizontal. And then the other thing that you can, or that you will need is the equation for finding the focus. So c squared is equal to a squared plus b squared with the hyperbola. So different from the ellipse where it was a minus sign, for the hyperbola it's a plus sign. All right, so let's do some examples here. And we have first identify the vertices and the foci of the hyperbola with the given equation. So we are asked to find the vertices, the foci, and I'm also going to add the center because it's pretty easy. We have no h or k in there. That means my center is at 0, 0. My a value is 7, and my b value is the square root of 32, which we don't know the square root of 32. We can simplify that. 32 is 16 times 2, so that would be 4 square root 2. Okay. Now, we will need our C value, so we will have to solve for that. But before I determine that, notice the Y value is first, that's positive, and the X is negative. So that means this is a vertical hyperbola. Okay, so I can go ahead and kind of, even though it doesn't ask us to graph, it might be a helpful visual for us. So I'm going to go ahead and just draw a real brief sketch here. And we know this is vertical. I know my center is at 0, 0, and I know my A value is 7. So I'm going to be going up 1, 2, 3, 4, 5, 6, 7, and down 7. 1, 2, 3, 4, 5, 6, 7. And those are going to be my vertices. So my vertices are at 0 and positive 7 and negative 7. So I'm going to write plus or minus 7 just to combine it in one point. Again, you could also list it as 0, 7 and 0, negative 7. And then my foci, remember the foci, you find c squared is equal to a squared plus b squared. So in this case, that would be 49 plus 32. Well, 49 plus 32 is 81. So C, that's C squared. So C is equal to 9. So we go an additional 2 more values to find our foci. And that means they would be at 0 plus or minus 9. Or again, you could write them as separate points like we did with the vertices. Right, so that is our first example. The next one says, what is the standard form of the hyperbola that has vertices plus or minus 6, 0, and foci at plus or minus 2 root 10, 0? So a couple things we need to do here. It doesn't tell us to graph, but again, that's a really helpful tool for us to do. So I'm going to go ahead and plot my vertices. So 1, 2, 3, 4, 5, 6. There's one vertex. 1, 2, 3, 4, 5, 6. The other one, and that means my center is right in between. So my vertices and my center. Okay, so they asked for the equation, and if I have vertices here and here in my center, that means that this is going to be a horizontal hyperbola. So the equation I should be using then would be x minus h squared over a squared minus y minus k squared over b squared equals 1. And my center is at 0, 0. So I already know h and k are 0. So I already know that what I'm going to end up with here is going to be x squared and then minus y squared and then equal to 1. And I can already see that my a value is this distance here. A is equal to 6. So a squared would be 36. The only other piece that I'm missing is my b squared value. Now, they told us that our foci were at 2 square root 10. So 2 square root 10 is a little bit past 6. 2 square root 10, we can go ahead and we know that that's our c value. So c equals 2 square root 10. And I can square both sides of that to find c squared. So then c squared is equal to 2 squared is 4, and the square root of 10 squared would be 10. So 4 times 10 is 40. So now that I know c squared and I know a squared, I can find b squared. So I have c squared is equal to a squared plus b squared. And c squared is 40, and a squared is 36. And I can subtract 36 from both sides, and I get 4 is equal to b squared. And I actually don't need b, I just need b squared. And now I have the equation for that hyperbola. Okay, so the next one says, what is the standard form of the equation of a hyperbola that has vertices 0, negative 2, and 6, negative 2? So based off those points, I can already tell this center is not at the origin. So let's go ahead and plot those points and get a visual kind of what's going on here. So I have 6, 1, 2, 3, 4, 5, 6, negative 2. And that's one vertex. And then 0, negative 2 is my other vertex. So that is a V vertex. And that means my center is halfway in between. So 0 to 6, halfway in between would be at 3. And that's my center. And so I can see that my A value here is 3. And I can see that this is a horizontal hyperbola. So again, I'm using that same formula that I used in the previous example, that x minus h squared and a squared and minus y minus k squared over b squared. And I already know my center is at 3, negative 2. So I have my h and my k. I have my a value. I need to find my b squared value in order to plug in. So let's go ahead and set up what we already know. We have x, we know this is horizontal, so we're using that same equation like we just said. X minus h, which is 3, squared. And my a squared is 3, so this will be 9, minus y minus negative 2, so that'll be plus 2 in here, squared, equals 1. And we just need to find our b squared value. Okay, so I'm told that the foci are at negative 2, negative 2. And so that would be right here. And then 8, negative 2 here. And so the distance from the center to my focus is 5. So C is equal to 5. So C squared is equal to 25. So then C squared is equal to A squared plus B squared. 25 is equal to 9 plus B squared. Subtracting 9 from both sides, 16 is equal to B squared. So the equation for that hyperbola would be this right here. Okay. Now the next example gives us an equation and asks us to graph. So what we want to do, changed the lighting quite a bit here. Let me see if I can fix that. So the next example here, we have y squared minus x squared. So I already know before I even start this problem, this is going to be a vertical hyperbola. And there's no h or k in there, so I already know that my center is 0, 0. So this question asks us to find several pieces. I'm going to add a couple to the list here. Let's also find the center, which we just said what it was, the vertices, the co-vertices. Not exactly co-vertices because they're not points on the graph, but we'll call them that. The foci, the asymptotes. Okay. So this is the first time we'll be finding the asymptotes, so I'll show you how to do that. Again, our center is 0, 0, and we know that it's a vertical hyperbola. So my A value is 8 and my B value is 6, the square root of those two numbers. So I've already set up my graph here to be counting by twos because I've got some larger numbers that I'm working with. And since this is a vertical hyperbola, my vertices are going up from my center and down from my center. And that's going to be a distance of 8. So 2, 4, 6, 8. And 2, 4, 6, 8. And those are my vertices. Then I have my center here. And then my co-vertices are going to be out to the side. And those aren't actually points on our graph, but they help us to draw that box for our asymptotes. So counting out 6 in each direction, 2, 4, 6, 2, 4, 6. And now what we're going to do is I can actually draw my entire graph now. Once I have all these 4 points here plotted, I'm going to just real lightly in pencil here draw this rectangular box that's created from those 4 points. And we need to go over it one more time just because on the video, I don't think you can see it as well as you can on my paper. And then through the corners, so this corner, through the center, and through the opposite corner, that gives us one of our asymptotes. And then through this corner, the center, and out the other corner gives us the other asymptote. Okay. Now, my vertices are here and here, And so the graph of my hyperbola is approaching each of those asymptotes, going through that vertex, and then going up and down. So we already have our graph done. So we've already found our vertices. Let's go ahead and write what they were. 0, 8, and 0, -8. So 0, positive, and -8. And then our co-vertices were at 6 and -6, 0. So plus or minus 6, 0. We have not found our foci yet, and I have not written the equations of the asymptotes yet. So let's go ahead and find the focus next. C squared is equal to A squared plus B squared. So C squared is equal to 64 plus 36, and that would be 100. So C equals 10. So our foci are inside the curves of the hyperbola. So up 2, 4, 6, 8, 10, and down 2, 4, 6, 8, 10. And those are the foci. And those points then would be 0 plus or minus 10. Last thing we need to find is the asymptote. And you'll notice I mentioned when we went over the formulas for the hyperbolas, I was going to try and make it as minimal information for you to memorize as possible. I haven't referenced any formulas other than the formulas for the hyperbolas. I haven't had you memorize how to find the asymptotes or vertices or anything like that. We're just using what we know about A, B, and C to find all of those pieces. So for finding the asymptotes, we're going to use y minus y1 equals m times x minus x1. We used that at the very beginning of the semester back in chapters 1 and 2 for writing linear equations. This is called point-slope form because if we have a point and we have a slope, we can find it. Now, that point that you're plugging in here, the x1, y1, that's always going to be your center. So in this case, we're plugging in 0 for y and 0 for x. Okay. Now our slope is going to come from this box. So if you start at your center and you go to that top right corner, we went up 2, 4, 6, 8, and over 2, 4, 6. So we went up 8 and over 6, our rise over our run, our slope, just like when we wrote linear equations back in the beginning of this class. 8 over 6 reduces to 4/3. And we have both the positive slope version of that line as well as the negative slope version of that line. So I have plus or minus 4/3 as my slope. And you can leave it exactly like this. Since this has zeros, if you wanted to simplify, you could write y equals plus or minus 4/3 x minus, or you wouldn't write x minus 0, then you would just write x. But you can just leave it like this. In fact, I'd prefer if you get in the habit of leaving it just like this, because when your center is not at the origin, I definitely want you leaving it in this form. So I'm going to write y minus 0 equals plus or minus 4/3 x minus 0. And that's how we find the asymptotes. All right, on to the next slide. We have one more example of graphing a hyperbola, and you'll notice here that this hyperbola is not in standard form. So like we did with the ellipse, we're going to need to use completing the square. And so we're going to be doing completing the square twice again. I have 9x squared and then minus 36x. So 9x squared minus 36x plus something, because we're going to complete that square. And then minus 4y squared minus 40y plus something. And then this is going to be equal to, if I add 388 over, that'll be positive 388. And whatever we add to one side, I have to add to the other as well. Okay. So remember, in this box, when we do completing the square, we did this in the previous video, your b value divided by 2 squared. But remember, with completing the square, we want our a value to be 1. And right now, my a value is 9. So I'm going to factor out 9, and I'll have x squared minus, not 36, 36 divided by 9 is 4, and then plus something. And then I'm pulling out a -4, so I need to be careful here with my signs because they're all switching. So pulling out that -4, I have y squared plus 10y, and then I'm adding something here. And then on the other side, I have 388, and then I'm adding, what I'm really adding to this side is 9 times that something. And then what I'm really adding over here is -4 times that something. Now, again, what's going in that box is that, and in fact, I'm going to get rid of this line here, is that b squared, or b divided by 2 squared. Okay. And that's also what's going in here, or rather not that one, in here, for this b value. Okay. And that's also what's going over here. So in this case, my b value is -4. -4 divided by 2 is -2. -2 squared is +4. And that's what's going in these purple boxes. And then here in this teal box, we have my +10 is my b value. So 10 divided by 2 is 5. 5 squared is 25, and 25. Okay. So the hardest part with these problems is keeping the steps organized. The math we're doing is not that hard, but it's the keeping all of this organized. And I really like using color coding with this because I think it helps keep everything organized. And writing the 9 times the box and the 4 times the box helps you remember that you're actually adding 9 times 4 and -4 times 25. All right, so this becomes 9, and then remember this gets factored, so x and then b divided by 2. So this, running out of room here, this 2 here is b divided by 2. Okay. And then -4, and I have y plus 5. Again, this is, oh goodness. I'll just go through it. This is b divided by 2. Okay. So here where it was -4, it stayed negative. Here it was +10, it stayed positive. And that's squared. And then this is going to be equal to 388. And then 9 times 4 is 36. And then 4 times 25 is 100. So 388 plus 36 minus 100 is going to give us 324. And then I'm going to divide both sides by 324 because I want this equal to 1. And those fractions reduce. 324 divided by 9 gives us 36. So this becomes x minus 2 squared over 36 minus 4 and 324 reduced to 81, and y plus 5 squared equals 1. And now we have our equation in standard form. Now it's much easier for us to answer all the pieces of information that we want to find and go ahead and graph. Just so we get some practice with it, I am going to find all those same pieces I did with the previous example. So I'm going to list all of those out here. I want to find the center, the vertices, the co-vertices, the foci, and then the asymptotes. Okay, so we want to find all of those pieces. From my equation, I can see my center. It's at 2, -5. Remember, h is always with the x and k is always with the y. And so let's go ahead and plot that point, 2, -5. Okay, there's my center there. And let's see. I think actually I might, well, no, I don't want to count by 2s. I am going to adjust my graph a little bit here, though. So bear with me while I adjust this line here that I'd like to actually have a little bit here, higher. This is going to be tight to try and fit on this graph, and in fact, I can already tell you it's not going to fit, but because we're dealing with some odd numbers here, I don't want to count by twos, so we're going to just make that back to what I wanted it to be. All right, so I'm going to create my x-axis here, right here. Okay. So my center is at 2, -5. So 1, 2, 3, 4, 5. 2, -5. That's my center. We know that because x is positive that this is a horizontal hyperbola. So I'm expecting to see this horizontal hyperbola here. And my vertices, my A value is 6 and my B value is 9. So I'm going out to the side 6. So 1, 2, 3, 4, 5, 6 for my vertices. 1, 2, 3, 4, 5, 6 for my other vertex. And I can go ahead and write those points. So this is 1, 2, 3, 4, 5, 6, 7, 8, -5, and 1, 2, 3, 4, -4, -5 for my two vertices. My co-vertices are going to be up 9 and down 9. So those are going to be off the grid here a bit. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So that is at 1, 2, 3, 4, 2, 4. And then down 9, 1, 2, 3, 4, 5, 6, 7, 8, 9. Again, off the grid a bit there. That's okay. That's going to work out just fine. And that was down 9 from -5, so that's -14. So this is at 2, -14. Okay. So those are co-vertices. I'm going to use my pencil real quick to draw my box with that information. Through my vertices, my co-vertices. And then we can go ahead and draw our asymptotes through those corners. So I'm drawing over a lot of my writing here. In fact, let me zoom out a bit so you can see it a little clearer here. Through my corner, through my center, and out the other corner. And then again through this corner, through my center, out the other corner. And then this is a horizontal hyperbola, so I know it's going through my vertex and approaching those asymptotes. And maybe in hindsight, I should have counted by twos, but already on this train where it is. So there's my hyperbola. And I've already got my graph. The only other things I need are my foci and my asymptotes. So for the foci, I need c squared is equal to a squared plus b squared. So c squared is equal to 36 plus 81, and that's going to be 117. So c is equal to the square root of 117, which is approximately, let's see, 10.8. Okay. So I know I'm going out 10 from my center and out 10 from my center to plot my foci. So from my center, going out 10. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And 1, 2, oops. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And there's the other focus. Now we added, and it's not exactly 10, it's 10.8. So I guess I should have gone a little closer to 11. But what we want to use is the square root 17. So when I write my points for my focus, I'm starting from my center. That entire area, my y value is -5. So for my focus, my y value is -5. My x value starts at 2, and then I'm adding and subtracting the square root of 117. So that's the way you can write your focus as the exact point and not a rounded point. And then for our asymptotes, for my center, I'm going up 9 and over 6. So my rise was 9 and my run was 6. And we have both the positive asymptote and the negative asymptote. So plus or minus. So that'll be plus or minus 3 over 2 when we reduce. And then y minus y1 equals m times x minus x1. Remember, we are plugging in our center. So my x value is 2, my y value is -5, and my slope is 3 over 2. So my asymptotes then, plugging in -5, this becomes y plus 5 equals plus or minus 3 over 2. And then in parentheses, x, and then minus 2. And those are all of the pieces we needed to find. And that brings us to the end of section 2.